We will discuss about conjugation, that is the part of organic chemistry and Dr. Pharmacy first semester. Foundational concepts, understanding the architecture of biosystems. What is conjugation? Conjugation occurs in a system of connected p orbitals with delocalized electron and compounds with alternating single and multiple bonds. This overlap creates a continuous tunnel for electrons, significantly lowering the overall energy of the molecule. It increases molecular stability, influences physical properties, alters chemical reactivity. We have structural requirements, p orbital overlap. At least three or more adjacent atoms must have unhybridized p orbitals. This allows the pi electrons to spread across the entire system rather than being localized between two atoms. Planarity, the atoms involved must lie in the same plane. Any twisting of the molecule disrupts the parallel alignment of p orbitals, breaking the conjugate's path. You can see in this diagram p orbitals in the same plane, overlap possible, and in this p orbital at 90 degrees. Next, we have types of conjugated systems, pi-pi system, alternating double and single bond example 1,3-butadiene, and lone pair pi, lone pair adjacent to a pi bond example vinyl chloride, and radical pi unpaired electron adjacent to a pi bond example allyl radical. Next we have stability, heat of hydrogenation, comparison of energy released during hydrogenation. The unit is kilojoule per mole. Lower energy release indicates higher initial stability and butane localized. Then we have 1,3-butadiene conjugated. In 1 butane, it's about 126 kilojoule per mole, and 1,3-butadiene is 236 kilojoule per mole. So the expected value for two isolated bond is 252 kilojoule per mole, and conjugation saves 16 kilojoule per mole of energy. Conjugation and light. As conjugation increases, the energy gap between HOMO and LOMO decreases. This shifts the absorption maximum lambda max toward longer wavelengths bathochromic shift. You will study about bathochromic shift and pharmaceutical chemistry in the sixth semester and third year. So next we have the ultimate case, benzene. We will aromatic conjugation. Benzene represents a closed loop of conjugation. The electrons are perfectly delocalized, making it exceptionally stable compared to open chain trienes. Bond lengths are all identical, 1.39 angstrom, intermediate between single and double bonds, highly resistant to addition reactions. And key effects of conjugation, thermodynamic stability, conjugated dienes are more stable than isolated dienes. Bond length alteration, single bond in a conjugated system. C2, C3, and butadiene is shorter than a standard alkane single bond, and color expression. Extended conjugation in molecule like beta carotene allows for visible color absorption. Chemical reactivity favors one for addition over one to addition in many scenarios. As we see, applications in pharmacy and pharmacology, conjugation is vital for drug action stability. Many drugs contain aromatic or conjugated systems that act as a pharmacophores, ensuring the molecule fits perfectly into biological receptors via pi stacking interactions. An example is aspirin and sulfonamides rely on their conjugated phenyl rings for structural rigidity and electronic properties. And then we have conjugated versus isolated systems feature pi orbital overlap, and conjugated system is continuous across 3 plus atoms, and isolated system interrupted by sp3 carbon. And the stability, conjugated system high, low potential energy, and isolated is lower, high potential energy, and feature UV absorption. Conjugated system longer wavelength lambda visible range possible and shorter, and isolated is shorter lambda for UV, and bond length and conjugated system partially equalized, and isolated system is distinct bond. Thank you for your attention. If you have any question, you can ask in the comment section.